Good morning, friends. Today we are going to solve some of the JEE problems up to motion in straight line topics, which how much we are completed. We are completed at a linear velocity and speed concept we completed. Different types of velocities also we completed. That's why we are going to solve some of the problems which they are asked in JEE exam. This is the problem which is asked in JEE 1999. The problem is here. In 1.0 seconds, a particle goes from point A to point B moving in a semicircular radius 1 meter. The magnitude of the average velocity they are asking. So the average velocity formula you already know. Average velocity is equal to displacement by time, total displacement by time. So average velocity is equal to V average is equal to total displacement by total time taken. So in this equation, will you please, in this diagram, will you please look on this one? The particle is moving from A to B like this. So will you please look on this one? This is the displacement. This is the distance graph we will get. The displacement is nothing but it is the circular path is there, semicircular path is there. So the distance, the displacement is equal to, it is the it is the diameter of the circle we will get, that is equal, diameter is equal to 2r. But in this equation the radius of the circle is equal to 1 meter. They are provided 1 meter. Then that, what is the displacement here? 2 into radius of the circle is equal to 1 meter divided by total time. How much time is taken to complete this process? 1 second is completed, that is equal to 1 second is completed, that is equal to 2 meter per second we are having. This is the average velocity of the particle. Which one is the correct option? Correct option is the B option is the correct option. Now B option is the correct option, very easiest one. Now let me go to the another one. A particle is moving with speed v is equal to b root of x along positive axis. Calculate the speed of the particle at a time t is equal to tau. Assume that the particle is at origin at t is equal to 0. So this is this is also problem we are having average velocity, average speed only. The average speed v average is equal to, that is equal to total displacement by total time, that is equal to dx by dt. This formula also we can use, but in this problem, to substitute the in this problem we don't having the they don't given dx by dt term, so we need to modify the given equation up to this model. So will you please look on this one? What they given? The velocity is equal to b by root x, that is the velocity of the particle is equal to v is equal to b into root x they are given. So v is nothing but that is equal to dx by dt term is there, but here v is equal to root x is there. If t term is there, directly we can substitute the given time in this equation, but t term is not there. But I am modifying this equation, that is equal to dx divided by root x term. I bring this one, that is equal to b into that is equal to b into dt is there. Just dt I send this side, root x I send this side, that is equal to integrating this equation one time. So integrating on both sides. I am integrating on both sides. What will happen? So that is equal to integral of root x is nothing but x power minus 1 by 2 into dx, that is equal to b is the constant, integral of dt we will get. So integral of x power 1 by dx means we know the formula, integral of x power n into dx is equal to formula, that is equal to x power n plus 1 divided by n plus 1 formula is there. Integral of 1 into dx is equal to, that is equal to, you will get dx only. So now I am using this formula for this one and this formula for, in this case, this one. So just to substitute this one, that is equal to x power minus 1 plus 1 divided by minus 1 by 2 plus 1, that is equal to b into t. This is the formula we are getting. Now will you please look on this one, this formula, what we will get? Minus 1 plus 1 by 1 is equal to x power 1 by 2 divided by 1 by 2, that is equal to b into t we are getting. So for this one I am getting, our goal is to find out the dx by dt term. Dx by dt term I am getting. So square on both sides. What will happen? X divided by 1 by 4 is equal to b square into t square we will get. So send this 4 that side also, that is equal to x is equal to 4b square t square we are getting, that is equal to b square t square we are getting. Now what is the formula we are having? x is equal to 4 b square t square we are having. This is the formula we are having. Now will you please look on this one. 1 minute. Here is the 1 by 4 is there. Now I need to send 1 by 4 this side, means 1 by 4 only we will get. So here I need to write 1 by 4. 1 by 4 into b square t square. Right, remodify this one. S. So that is equal to x is equal to 1 by 4 into b square into t square we are getting. Now our goal is to get the equation of dx by dt. So differentiate this equation with respect to time. So differentiating above equation with respect to time. With respect to time I am doing, that is equal to dx by dt is equal to, now I am doing dx by dt is equal to 1 by 4. Now here is the b square is the common term. If you do differentiation, means you need to know the formula. D by dt of t power n is equal to, what is the formula? N into t power n minus 1. That is the formula. Here n instead of n, what we are having? 2 we are having. T into t power 2 minus 1 we will get. That formula is equal to 1 by b square into 2 into t we are getting. So 2 1 jar, 2 2 jar, that is equal to b square t by 2. We are having the formula. Now what they are asking, this is the velocity of the particle. Now once again I am writing dx by dt is equal to b square by t into 2. Where they are asking this velocity? According to the problem, where they are asking? According to the problem, they are asking the velocity at time t is equal to tau. So just to substitute the time t is equal to at tau, that is equal to t is equal to tau. That is equal to b square tau divided by 2. B square tau divided by 2. This is the velocity of the particle at given time t is equal to tau. So this is the value. Which one is the correct option? So the correct option is b square tau by 2. This is the option B. Here also option B is the correct option. So option B is the correct option. Now let me go to the another problem. A particle, it is the problem is given in 1983. A particle is moves in a circle of radius capital R in half of the period of the revolution. It's a displacement dash and a distance dash. They are asking. So the time period of this, time period is equal to t. So let time period is equal to capital T. Half of the time period is equal to t by 2. Half of the time period is equal to t by 2 will get. So what does it mean by time period? To complete, to execute one rotation, the time taken to execute the one rotation means that is the time period. Is it correct only, na? So now how much time we are taking, that is the very important. Now let me come to this one. So if one rotation means if you start this particle and again it will meet to the same position, this is the time period. So the time taken, the t is equal to time period. Half of the time means it will complete only half rotation. Is it correct only, na? So in time period, it is the time period revolution. So what about here? Here half of the time we are taking. Half of the time period it is. Half of the time period means what is the position of the graph? It is making like this. It is moving like this. So from this point to this point it will be. Let me take A to B. In this first problem, look like it is appearing. Let me take the radius of the circle is capital R. As per the problem, let me check, is there given any capital R? Yes, the radius of the circle is capital R they given. So now what is the displacement? Displacement means the total path followed by the particle in the motion. That is the total path, means this is the path followed by the particle. So A to B, how much? This is the half of the circumference of the circle. Total circumference of the circle is equal to 2 pi r. Half of the circumference is equal to pi r. Pi r is the displacement. Sorry, pi r is the distance. So what is the distance? Distance is equal to pi r. What is the displacement? Will you please look on this one? Displacement means a final position, initial position, shortest path of the object. So in this one, this is the r, this is also r. How much distance it is having? 2r. 2r is the displacement. So the 2r is the displacement. This is the formula. Now let me go to the another problem. What is the problem they are given? In JEE 1979 they are given one graph here, time and position graph. They are asking that whether this graph is correct or whether this graph is wrong. We need to comment this one. So will you please look on this one? This graph is wrong. How it will wrong means we can easily explain. Let me take any one of the time. I am taking one of the time. Will you please look on this one? This is the position. Position means object existing possibility. So will you please look on this one at a given time? Let me take this time is equal to 10 seconds. Something I am taking. In 10 seconds, the object is existing in this location as well as in this location. This graph is drawn for one of the particle position with respect to time. See, in 10 seconds the object is existing at the position of this position of x1 value, at the position of x2 value. It is impossible one particle may not be exist at a same time at two different positions. That means this graph is wrong because of the particle may not be exist at a same instant of time. It may not exist in the two different positions. That's why this is the wrong graph. Now let me go to the another problem. So it is the JEE 2021 problem, recent problem. So the instantaneous velocity of the particle moving in a straight line is given by v is equal to alpha t plus beta t square, where alpha and beta are the constant. The distance traveled by the particle between the 1 second to 2 seconds they are asking. They are asking distance. But one condition you need to know, will you please, the particle is moving in straight line. This condition is very important. Without this condition this problem may not be solvable. Now let me take what is the velocity of the particle they given. Velocity of the particle, will you please remember, velocity alpha t plus beta t square. So alpha t plus beta t square, where alpha and beta is the constant. So will you please look on this one? Alpha and beta is the constant, means what is the velocity formula? It is the total rate of change in displacement, that is equal to ds by dt is equal to alpha t plus beta t square is there. Now to get the displacement means we need to integrate this equation. Now that is equal to ds is equal to alpha t plus beta t square into dt. Now integrating this above equation with respect to suitable integration, let me take, I am starting from S1. So initial point of the Si to S final. So the time is I am starting T1 to T2. I am starting T1 to T2. So that's why I am doing integrating this equation. What will happen? So if you do this one, we already have the formula, integral of was something 1 into dx is equal to, will get the x value, here ds is there. Then what is the formula here? This is the formula I am writing here. Integral of ds, that is equal to s we will get, where initial displacement, final displacement, that is equal to dt will come to this place. Now integrating this again, alpha is the constant, you can keep it out. So integral of t into dt. So alpha is outside, where t1 to t2. Plus in the similar manner b is alpha beta t square, integral of beta I am taking integral of beta t square into dt. So will you please look on this one? One more formula is there, you have already known, integral of x power n into dx is equal to x power n plus 1 divided by n plus 1. So instead of here t power 1 is there, here t power, instead of n we are having here 1, here 2 we are having. That's why we will get the alpha into t1 plus 1 divided by 1 plus 1, plus we need to substitute the limits also, where t initial value, t final value, t initial value, t final value, t initial value, t final value, that is equal to plus beta into t power 3, that is equal to 2 plus 1 divided by 2 plus 1. Again t initial value, t final value we will get. So better to write once again. Okay. Now come to this one, this is equal to, left hand side this one is having alpha into t power 1 plus 1 divided by 1 plus 1. So where t initial value, so t of initial value, t of final value, plus beta into t power 2 plus 1 divided by 2 plus 1, where t of initial value, t of final value. Now I am writing in the another equation, where left hand side is equal to s sum. Will you please look on this one? The left hand side is equal to s final value displacement minus initial value displacement, that is equal to, now I am taking the final value displacement minus initial value displacement is equal to, now alpha into, will you please look on this one, alpha into t square divided by 2 is there, t final value minus t initial value. So now I am taking 1 by 2 alpha I am taking common, so t of square final value minus t of initial value square. This is the first one. Again, if you go to the next one, so here is the 1 by 3 is the common term, b by 3 is the common term, t cubed is there. I am substituting upper limit minus lower limit. So that is equal to beta by 3 into t of final whole cubed minus t of initial whole cubed. This is the formula we are getting. This is the displacement of the particle. So now it is the final displacement minus initial displacement. Then that is the displacement between the two time. If they are provided the time, final time and initial time, we can easily find out that what is the total displacement covered by the body in the particular time we can get. But one condition they provided, what the condition provided means the particle is moving in the straight line. They are asking the distance. If the particle is moving in the straight line, then the distance is equal to displacement. Both are same. The distance must be equal to the and also the particle moving in the straight line, it should not come back. Then only we can use this formula. That is how we are assuming that the particle is moving straight line, distance is equal to displacement. That's condition I am applying here. As the particle is moving straight line, as the particle is moving straight line, what is the condition? Distance is equal to displacement. So displacement formula I can use as the distance condition. Then what is the they are asking? They are asking that the distance value at where 1 second and 2 seconds. The final time is equal to 2 seconds, initial time is equal to 1 second. Now substitute this t is equal to 2, t final is equal to 2 seconds. Here t final is equal to 2 seconds, t initial is equal to 1 second. Now substitute in this one. So alpha by 2 into t final is equal to 2, that is equal to 2 square minus 1 square, plus beta by 3 into t square, that is equal to 2 cubed minus 1 cubed. So then that is equal to alpha by 2 into 4 minus 1 plus beta by 3 into 8 minus 1. Now what we will get? This value is equal to 4 minus 1 is equal to alpha by 2 into 3 plus beta by 3 into 8 minus 1 is equal to 7. That is equal to 3 by 2 alpha plus 7 by 3 beta. This is the formula we are getting. Now let me check this. Yes, will you please look on this one? So 3 by 2. Which one is the correct answer? 3 by 2 alpha plus 7 by 2, 7 by 3 beta. So this option is the B is the correct answer. All options are we are getting B only, na? Okay, thank you. This is about the problems which are given, some of the problems which they are asked in the previous JEE question paper. Now tomorrow I need to we will plan to solve some more problems which are given in the concept which we are completed up to now. Thank you for listening. Thank you, ma.